So we are going to talk about slant, or also known as oblique asymptotes. So these are horizontal asymptotes that come from the case when your degree is larger in the numerator. So we saw that if the degree was the same in the numerator and the denominator, then you take the leading coefficients. If the degree was larger in the denominator, then the horizontal asymptote is y equals 0. But if your degree is larger in the numerator, then you get stuck. Because if you're plugging in very, very large numbers of x, like 1,000 and then 10,000, and then you keep going like that, you are having a function, in this case, that's growing out to infinity. So what does that look like? What does that slant asymptote look like? And so in order to find it, what we need to do is divide the denominator into the numerator, or do our synthetic division. So you can set it up either as long division if you'd like to do long division, or as synthetic division. If we're going to do synthetic division, then in this case, you're going to divide 2 into 1 for the x squared. Remember, a placeholder because we don't have an x term, and then 1 for a constant. We carry down the 1, multiply 2 times 1, add 0 plus 2, and then multiply 2 times 4, or sorry, 2 times 2 is 4, and then add 1 plus 4 is 5. So what we get is this, x plus 2 plus 5 over x minus 2. So again, think about x getting very, very large. 5 over x minus 2 is going to go to 0. So your slant asymptote, or your horizontal asymptote, in this case, and I'm going to abbreviate that as HA, is y equals x plus 2. So when you go to graph this, let's make a graph here. Let me put it down here. When you go to graph this, it doesn't have to be exact, but let's make it as good as we can. So we've got a y-intercept of 2 and then a slope of 1, so up 1 over 1 repeatedly. So what's going to happen is as your function goes to negative infinity for the x, your function is going to follow this dotted line. And as x goes to infinity, your function is going to follow the dotted line. So you're going to end up going out in this kind of diagonal direction, or a slant. You're going to follow the slant. And so notice that if you hadn't done synthetic division, think about x getting really, really large. The 1 right here isn't going to play any effect when you're plugging in really, really large numbers of x. Also, this minus 2 is going to have no effect. So you could kind of think of this function, well, you can think of this function as f of x is kind of like, so approximately like x squared over x, which is just equal to x. So notice we're being much more precise with the synthetic division or the long division, saying that our slant asymptote is y equals x plus 2. But you could just look at it and say, well, my slant asymptote is going to be x. And so if you are just sketching and not answering a question asking specifically for slant asymptote, you're not wrong by saying x. It's just a sketch, and as long as we get that slant in the right direction and approximately with the right function, then we're good.